Hello and welcome. Today we're going to compare the coding capabilities of 8 different large language models. The goal is to see how each one performs on the same defined task with the same simple prompt. The challenge was to recreate a Galton board, a device used to demonstrate the bell curve or normal distribution. This requires the AI to understand the concept, generate the necessary HTML and JavaScript code, and create a working visual simulation. The prompt for each was simply, let's recreate the Galton board. Let's look at the results. First, we have Claude 4 Opus. As you can see, it produced a very clean and functional simulation. It includes controls for the number of balls, the number of peg rows, and the animation speed. The simulation works correctly, forming a clear bell curve in the histogram below. The only minor improvement would be adding borders to contain the visualization. Based on its performance, I've given it a score of 8 out of 10. Next is Claude 4 Sonnet. This model also produced a working simulation. However, it is more basic than the Opus version. It lacks containing borders and doesn't have a single drop point for the balls at the top, which is a key feature of a Galton board. It's functional but less complete. I scored this one a 6 out of 10. Here is the result from Kimi V2. It successfully created a functional simulation that demonstrates the concept. The balls drop and form a distribution at the bottom. Similar to some of the others, its main missing feature is a set of borders to properly frame the simulation. Overall, a solid result. I gave Kimi V2 a 7 out of 10. Now let's look at Grok 4. This is another very strong result. The simulation is well organized, works as intended, and correctly generates the bell curve distribution. It successfully understood and executed the core requirements of the prompt. For its performance, I also gave Grok 4 a score of 8 out of 10. This next result is from O3 Pro. It appears to have misunderstood the prompt. The code generates a simulation of only a single ball and does not create the triangular peg structure required for a Galton board. Because it missed the main objective, it received a score of 4 out of 10. Here is the attempt from GPT 4.1. This simulation is not functional, the code is disorganized, and the visual output does not resemble a Galton board. The pegs are not in a triangle and the balls move without following the expected physics. This was the least successful result, which I scored as a 2 out of 10. Next up is Gemini 2.5 Pro. This model correctly generated the triangular layout of the pegs, which is a key part of the challenge. However, the simulation is flawed. As you can see, the balls failed to stay within the intended area, indicating an issue with the simulation's borders or physics. Because it understood the structure but failed in the execution, I gave it a 5 out of 10. Finally, we have DeepSeek's Roan 0528 model. This is another competent result. It successfully creates the simulation and the histogram at the bottom. The pegs are laid out correctly, and the simulation runs smoothly. For a slightly more accurate simulation, it could benefit from more variability in the ball movements, but it's a good result overall. I scored it a 7 out of 10. So after reviewing all the results, here's the final tier list. In the A tier, we have Claude 4 Opus and Grok 4. Both of which delivered excellent working simulations with additional features. In the B tier, Kimi V2 and DeepSeek, which created solid, functional boards that met the core request. C tier is for Claude Sonnet, which was functional but noticeably more basic. D tier contains Gemini 2.5 Pro, which understood the structure but had a critical flaw in its execution. And in the E and F tiers, we have O3 Pro and GPT 4.1, which were unable to correctly produce a working Galton board. This test shows that even with an identical prompt, the performance between different models can vary significantly. Thank you for watching this comparison. If you found this informative, please consider liking the video and subscribing for more tests like this in the future. Let me know your thoughts on the results in the comments below.